Number 4. The resistivity of a commercial quality copper is 0.686 micro-ohm-inch at 20 degrees Celsius. Determine cross-section in square inches and circular mills and resistance at 20 degrees Celsius of 121 pounds of this copper when the length is 600 feet. The weight per cubic inch of copper is 0.321 pounds. Okay. First, we need to recall the formula for resistance. The three formula for our resistance. If we recall the three formula for our resistance, that is R is equal to the resistivity length all over the cross-sectional area, and also the resistivity times volume over the square of our cross-sectional area. And the third formula is resistivity is square of length over the volume. Okay. Let's try to evaluate our formula. We are tasked to determine the resistance. So, the resistance is unknown. Determine the cross-section in square inches. That is our cross-sectional area. Okay. And the cross-section is in square inch and circular mil. That is our cross-sectional area. Also, we have a given the weight, the 121 pounds and the 600 feet. So, length is given. We have the resistivity of our copper is given. Then, the weight per cubic inch, that is your weight density. You have the total weight density. Okay. The volume is unknown. So in the problem, if you observe, resistance, cross-sectional area, and the volume is all unknown. Okay, let's start with the volume. We'll start with the volume. If you recall the formula for your weight density, your weight density is equal to the total weight over the volume. That's correct. So, therefore, our volume is equal to the total weight all over your weight density. Do we have our total weight? Yes, we have our 121 pounds. How about for our weight density? That is also given. That is 0.321 pounds per cubic inch. Okay? So, weight per cubic inch is 321 pounds. So, the weight density, the total weight is given, the weight density is given. Now, we can determine for our volume. Okay, solving for your volume. Therefore, your volume is equal to your total weight, that is 121 pounds, all over your weight density, 0.321 pounds per cubic inch. Okay. So finally, your volume is 376.9470405 cubic inch. We forgot to cancel out units. So we cancel out pounds, The remaining unit is in cubic inch. That is the unit for your volume. Okay? So this is our volume. Now that we have our volume, we can determine our R, right? We'll solve right away our R. So using our formula, R resistivity is square of length all over your volume. So let's solve it right away. So resistivity is given, that is 0.686 micro times 10 raised to negative 6 ohm inch. We have a length Yes, it's given. Our length is 600 feet. 600 feet. Okay, so 600 feet. So our unit for resistivity is in inch. So we convert feet to inch. In every feet, there are 12 inches all over the volume, which is we already solved our volume. Our volume is 376.94704.9470405 square cubic inch. Okay, so let's cancel out common units. So 600 feet converted to inch, so cancel out feet. So the remaining unit here is ohms square. This is squared, right? Look, squared. Okay, so the remaining units at the numerator is ohms and inch times square inch, that is cubic inch. That is also the same in our denominator. So we cancel out the square inch, we cancel out the cubic inch here. Okay? So solving for your R, don't forget the power of your length. By the way, we use the memory of our calculator. By the way, we save this at our alpha A. So our R is your R is 0.09434280198 ohms. So we save our R to alpha B. So we store it at alpha B. So we will not be writing the total decimal digits. Okay, moving on. So let's check our problem. Do we have our resistance? We already determined our resistance. We already... Now, the next problem is we need to determine the cross-sectional area. Looking back at the formula, we have our volume. Right? We have our volume. We have our resistance. We can determine the cross-sectional area. Or we can use this one. We can use the resistivity length all over the cross-sectional area, because in the second formula there is a power. It would be easier to use this one. Okay, I'd rather use the first formula. Okay, so moving on. Therefore, based on our first formula, your cross-sectional area is equal to the resistivity length all over the resistance, which we already determined. Now, solving for your cross-sectional area, substituting the value of your resistivity, that is 0.686 10 raised to negative 6 for your micro-ohm inch. And we have our length already given in the problem, that is 600 feet. We need to convert feet to inches. In every feet, there are 12 inches. Okay, all over our R, which is our B. We save it in our B, so we'll not be writing all the unit digit. So, okay, solving for your cross-sectional area. Before that, we need to cancel out common units. So the unit here is in ohms. So cancel out ohms, cancel feet, and the remaining unit here is inches times inches, that is square inch, which is the unit of your cross-sectional area. Okay, solving for your cross-sectional area, 0.686 times 10 raised to negative 6 times 600 times 12 over the alpha B. Okay, so your cross-sectional area here is 0 0.052 square inch. Let's review our problem. Cross-section area in square inch. Okay, so we already do our square inch. But in circular mills also. Here, we use our conversion factor here. This one. We use this conversion factor. Okay, so using our conversion factor, we apply it right away to our answer. Okay, so our answer times our conversion factor, that is 127.39544732 all over the 0.01 square inch. So if we multiply this with 0.01 square inch and 12732.395447352 circular mil, we cancel out common units. Square inch, the remaining unit is in circular mil. So finally, our area in circular mil is 66,658.87198 circular mil. Okay, so let's review our answers. So we have our area in a square inch and our area, cross-sectional area in circular mil. Our resistance in our volume.